Okay, you guys, today we're doing 12.4, so we're skipping 12.3. That's Algebra 2 trig topic. So 12.4, we're going to do geometric probability, which you kind of already did a teeny bit. I threw it in when we talked about area of shaded region and all that stuff. But I am throwing in doing the odds of something. This is not in your textbook, so I'll put a little star there, but I like to do the odds. So again, this is not in your textbook, so hopefully you guys are definitely watching the lesson because you need to know it. All right, so the odds are different than probability. Think like when you have games like baseball games or anything, they're like, what are the odds of the team winning today? They have a 12-5 ratio, or the odds of winning the lottery, 1 in a million. I mean, they're giving you odds, not a percent. So the odds are used to measure, so I should probably write this down. Odds, which again is not, I didn't mean percent, but I meant it's not probability. Okay, it's used to measure the chances in favor, so obviously 1 in a million, it's not really in your favor, of an event occurring, or the chances against. So you're going to see me use the word favor or against in an event occurring. Instead of comparing the measure of an event to the measure of the total, that's probability. So probability is the event over your total. The odds you are comparing to all the rest. And I will explain what that means. That's not supposed to be there. So it's comparing it to all the rest of the events. Okay, so for example, the odds in favor of an event occurring, you're going to put the number of outcomes in, let's just say, event A, because I want the odds in favor in A. And then on the bottom is, we can say, the number not in event A. So again, you can think it's what remains. And I'm going to do the examples to show you exactly what it means. The odds against. The against is just the opposite of favor. Okay? The odds against event A occurring, watch how you can do this, is the number not in, let's say, event A over the outcomes in A, or again, outcomes in A, is what remains. If you look, they're just the opposite of one another. So honestly, you can always, if I ask you for in favor, if you want, take what I want and put it over the remaining. If I want against, you can still take what I want, put over the remaining. You just have to take just flip it. Please know that you can write the odds as A over B with the line, or A dot dot B. It is never, never, ever, ever a percent. Star, always a ratio. That's why, again, when they say the lottery, the odds in favor, they don't say it's 100% or 2% or 1%. They say 1 in a million. You're comparing. 1 is you, and I don't know, millions of people in the lottery. So here's a perfect example. It says the probability of an event. So I'm giving you the probability of an event is 2 to 7. The odds of the event occurring. So if the probability of an event is 2 is what I want, over 7 is the total, then the odds that it occurs is 2. And then the total, these numbers have to equal 7. So 2, what remains? 5. So the entire group has 7, but the rest of the outcome only has 5. Hopefully that makes some sense. Let's do an example so you guys get a better understanding. All right. I just have papers everywhere. So it says, a card is drawn from a standard deck. Find the odds in favor of drawing a 10. All right. Think, how many 10s are there? Okay. I'll put A. There are 4 10s. And then you're putting it over what remains. Well, if there are 52 cards in a deck, 52 minus your 4 is 48. Now, never percent. So the odds of you picking a 10 is 1 to 12, or you could say 1 out of 12, 1 or 12. Remember, every fraction I want simplified. The odds against drawing a club. 2 ways. You can think about the odds of drawing a club and then flip it, or the odds against it? Okay, so let's do this, the odds against it. So how many clubs are there? 13. 13. So now look, you're going to be doing 52. You're minus your 13 on top. You should get 39. And then how many cards remain? 13. Do you see how that kind of happens? Like you can put what we want on the bottom, what remains? What we want on the top. So again, this is in favor. This is against. However you want to think of it. And again, we can simplify that, and that's 3 to 1. And again, hopefully you guys clearly see how you cannot put that as a decimal. As a percent. Okay, number 2. A standard 6 die is rolled. Find the odds in favor of rolling a 6. Okay, well, there's only 1 6, so 1 out of 6. Pretty, just messed that up. 1 6. 1 6. How many remain? 5. Careful, don't do what I just did, which is just me not thinking. The total has to be 6. The total is 52. The total is 52. Careful. The odds against rolling an odd number. So I know when someone says against, what I want is on the bottom. How many odd numbers are there? 3. What's left over? 3. So 1 to 1. Pretty good chance. Okay, last question on this. So it says a card is drawn from a standard deck. Here we go again. Find the odds in favor of drawing a heart. So how many hearts are there? There are 13 hearts. And you have to do 52 minus your 13. So 13 out of 39. So 1 to 3. And just so you obviously realize, the order matters. So what we mean here is this 3 to 1, it's pretty, of you drawing against a club, you're pretty high, right? You're pretty high of drawing against a club. 1 to 3 is very different, so your order matters. Whatever number I see is I know that this one is in favor and that's against. So, or not, this is what you have and that's left over. Drawing a queen. How many queens are there? There are 4. Oh, drawing against. Against a queen. So against, I put the 1 on the bottom. 4 queens. 48 cards remain. So it's a 12 to 1 ratio. That's pretty high. So that's how you guys do odds. Again, it's not in your textbook, so hopefully you guys watch that lesson. All right, let's go on to our probability, the geometric. So like I said, you already did it. Geometric probability. I threw this problem on here because it's in your textbook and you have a homework problem on it, so I want to make sure you guys can do it, but it's pretty easy. So it says point K is on ST, okay? What's the probability that K lies on QR? So again, when you're doing something like this, you want the probability of, let me just do it, everything. So what's the distance? You can kind of say the distance of QR from 2 to 14 is 12, right? 2 to 14 would be 12. And then 5 to 8, if you're going to find something landing on that K lands here, 5 to 8 is 3, so about 1/4 or 25%. That's all that was. Zero problem like that on your homework. All right, but this is what I really want to go into. This is like your geometric one, which is what you're going to see, which is pretty simple. So point S is in a region in R. The probability that S is in R is the ratio of the area that, basically I say the area that you want over your total. So if you want to jot that as a note, so what's the probability that you land in N? You're finding the area of the region that you want, so in this case N, over your total area. And that's how you're just kind of doing it. Okay, so let's take a look at our first example. We have 4 examples. Oh, where's that other paper? Crap. Well, I had another couple of examples. I might have to pause you and come back in a moment. But anyway, let's do the first one. So here you guys go. It says you throw a dart on the square dartboard. Your dart is equally likely to any point. Are you more likely to get 10 points or 0? Okay, well, let's figure out. Let's figure out the probability I land in the 10. And let's figure out the probability I land in the 0. Okay, so 10 is what you want. So this area, well, this radius is 3. It's a circle. So the radius is 3, so 3 squared pi r squared. You got to still know your area formula. So 9 pi over, you want the total. Remember, want over the total. The total is this. So if this is 3, this is 6, another 3, and this is another 3, which is 9. So if this distance is 9, then this is 3, 6, 9. So what's the length of the entire thing? 18, and that means this is also 18. So the area is 18 squared, side squared. So 324. Put it in the calculator. You get about 8.7% is the likelihood you'll hit the 10. Okay, let's figure out the 0. Well, we know the bottom is 324. What's the probability I get 0? Well, to land here, you have to find the area of the square minus the area of the large circle, and that'll give me this outside region. All right, so the area of the square, we all know, use parentheses, is 324 minus. Well, what's this radius? The radius was 9. 9 squared is 81. 81 pi. In your calculator, make sure you put parentheses, divide, and you're going to get about 21.5%. So it's more likely, because you got to always justify, to hit 0 points because you have a greater percent, greater probability. Something like that I need you guys to write. Okay, next problem. A game at the state fair has a circular target. Oops. The radius of 10.7. And it's on a square board measuring 30. All right, let's just make sure we're in the same units. Good. Players win prize if they throw a dot, and they hit this circular board. What's the probability the player is going to win? Okay, so here we go. Again, the area that I want is the area of this circle. So 10.7 squared times pi over area, what you want. Put that in the calculator, and you should get about 40%. Okay? All right, number 3. Same kind of question. A dart hits the square board. What's the probability it lands in the shaded? Oh, you guys can't really see, but this is the shaded. So for me to land in there, you want the area that you want. The area I want, you're going to take the square minus the 4 circles over the square. Okay, so the area of the square would be 4 squared, so 16. Now, if this distance is 4, that means each of these are 2, which means my radius is 1. So first we're going to do the area of the square minus, because you want, again, square minus your circles, and that'll give you the leftovers. You have 4 circles, so 4, the radius is 1, 1 squared is 1, pi, right? If you want, I'll just put that in there so you guys see. So it's 1 squared pi, because again, the diameter is 2, 2, 4, the radius is 1. So put that in your calculator. Let's see what we get. 16 minus 4 pi divided by 16. You get about 21.4. So we get A. You get 21. And I did have 2 other ones. Let's just see if I left it right here. Here they are. Okay, 2 other ones and you guys are done, just because I want to review this in case you guys forgot. All right, so the probability I land there. Okay, so we want the whole thing. So this is your equilateral triangle. I don't think you guys know that. Marking. Actually, no, it's not equilateral. Lied. Thought it was. It's isosceles. Yes. Okay, so they're saying this distance is 10. So that means this is 5 and this is 5. What was it? Wanted it to be equilateral. Why don't you review that? Anyway, so we want the area of the triangle on the bottom. That's the whole thing. And on the top is just this region. We want to land in this region. So in this region, we can say is half our circle. okay? So half the circle. So our radius is 5. 5 squared pi over 2, half of it, over, right, the area of half the circle. That's the area I want. Over the total, which is the triangle, which is your base, which is 20, times the height, which is 10, over 2. Base times height over 2. All right, let's see what we get here. So 25 pi divided by 2. Okay, so that's that one. Divided by 200 divided by 2. 20 times 10, right? It's 200 divided by 100. So you guys get about 39%. Okay? Last problem, I just wanted to review because you have the hexagon. I want to make sure you guys remember how to do hexagon. So you have a regular hexagon with the sides are 14, circular bullseye, the diameter is 3. What's the probability that the dart hits the target at the bullseye? Okay, so we want the area of the circle over the area of the hexagon. That was very bad. Okay, so if the diameter is 3, y'all know the radius is 1.5. So 1.5 squared pi over. Aha. How do we find the area of a hexagon? 1/2 apothem perimeter. So we got 1/2. Perimeter is going to be 14 times 6. So 84. Put this all in parentheses or just hit enter. And let's find your apothem, which you guys should be fine with by now. Here is 7, 7. You should know this is your 30, this is your 60. So apothem is 7 rad 3. Okay, let's put that all in our calculator. If you don't use parentheses in your calculator, do 1.5 squared times pi. Hit enter, and then do divide parentheses. 0.5 times 7 radical 3. Oops. 7 radical 3 times 84. Close parentheses. Do not get a very good odd. Your probability is about 1.4% or 1%. Doesn't tell you what to round to, but I put it on to the nearest 10 for that one. So that's part A. Part B, or 22, says estimate how many times a dart will hit the bullseye if 100 darts are thrown. I don't care if you threw 1,000 darts. The percent is never changing. It's still 1.4%. Does not change if you throw another one. That's still what it is. And then part C says find the probability the dart will hit the bullseye if the radius is doubled. Okay, so your bottom is still the same. So now let's double our radius. If your radius was 1.5, when you guys double 1.5, your radius obviously is now 3. So let's see what happens. To be honest, I don't know. 3 squared pi, enter, divide by parentheses 0.5 times 7 radical 3 times 84, close. You went up a little bit. You got about 5.5% or 5.6. Okay, so that's all you have to do. The area, again, you guys have done it before, but make sure you guys review the area of your different shapes, the area what you want over the area of the whole thing. That's your geometric. And then don't forget when you're doing the odds, the most common mistake with the odds, people want to do what I did before, which is like, what, the whole thing? It's the number in A over what remains. Odds against is just the reverse. But again, their total, you make note of this, total, the sum will equal the total of the events, something like that, right? So if you have 11, it just will be 5 and 6, it's equal. All right, you guys, good luck in the textbook. Bye.